Hello everyone, I am Vivek Dungana and I am junior computer science student here at Texas Tech, and today I am going to explain about my first hardware project for modern digital system design class, and this is my final prototype over here. This prototype consists of battery, some switches, here is a voltage regulator and some kind of gate, AND gate, OR gate and NOT gate. And in this project I'm going to demonstrate you how can you use such kind of gate to simulate the output behavior over here. For example, if I turn everything on, the light is on. So I'm going to explain you how we can simulate any kind of logic circuit in using those AND gate, OR gate and NOT gate. Okay, now let's go a little bit details about our project specification. The first of all, our project specification is given over here, and you can see it over here. Now the first thing I need to do is make a truth table, and when I make a table I can mathematically find what will be the desired output. So when I obtain a truth table and I'll get some kind of mathematical output in the form of 1 and 0, 1 mean high and 0 mean volt, then I will build a similar circuit in my breadboard over here. Now the one and most important thing is, how can I be so sure that this my circuit is simulating the exact same behavior as the assigned project? The first thing I can do is compare the truth table. Here is 4 switches over here, A, B, C and D. I can make it change to 1 or 0 and compare that with the truth table, and if all the result of truth table exactly match with my device output, my project is right. Okay, now let's dive a little bit more detail about the project itself. The first one over there is 9-volt battery. That battery is providing some kind of power to turn all these AND gate, OR gate and NOT gate. And the second part over here, this one is voltage regulator. The main job of this is to convert 9 volt into 5 volt. And the third important part is the switch over here. This is 8. There are 8 switches over here, but we are only using 4 right now. The main objective of this switch is to simulate our input behavior in the form of 1 and 0. The next one over there is an OR gate, which is taking input from C and D. Then the output from that gate is treated to input from the AND gate over here. Then another sequence over there is a NOT gate. Then we are again using another AND gate and OR gate. The circuit looks a little bit more complicated over here, but if you simply Google the data sheet and see how you can configure this gate, you can simply see the output. And the main important part over here is testing if my circuit is doing exactly the same thing as assigned in the project one. Okay, so this is my final prototype for the project, and I am going to show you how this output LED turn into 1s and 0 depending upon 4 input variable A, B, C and D. Here are 4 variables over here, A, B, C and D. Let me just turn the B first. Is turned on. Let me turn on everything over here, and the LED is still on. But if I turn off the B part over here, the LED is off. And on this figure, it is really difficult to see everything like what's going on. That's why I'm going to simulate exactly the same circuit in TinkerCad and compare with the Boolean table, and I can prove that this circuit is working exactly as inspected. Okay, now this is one of the most tedious part of the project. In this project, I do have prototype over here, but it is really difficult to show like everything what's going on using this real prototype. As a result, I develop a similar circuit exactly over here using TinkerCad. Now the main objective over here is I do have a table over here, and I need to prove that my circuit is working perfectly fine. To prove that, if I am developing something new, I can simply see the objective and know my circuit is working good. But right now, I am just comparing the output of this table and my circuit to see if my circuit is working good. The first thing over here is, let me start a simulation over here. On my table over here, when A, B, C and D is 0. Honestly, this part is one of the longest part, so if you feel bored, you can feel free to forward it or whatever you want. So let's check the first result. When A, B, C and D is 0, means false, the output is 1. So when all of the four A, B, C, D is false, the LED is on. And the same thing is over here. When everything is false, the LED is on. So the first condition is right. On the second condition, when A, B and C is 0 and D is 1. So let's change D to 1. The LED should be on. So let me change D to 1 over here. And LED is still on. So the second condition is right too. On the third condition, when A and B is 0, but C is 1 and D is 0. Let's change C to 1. Let's change C to 1 on my circuit too. And still LED is on, so the third condition is good. Let's go to the fourth condition over here. When A and B is 0 and C and D is 1, it should still be 1. And as my table says, the LED is still on, and even in the circuit, the LED is on. So my fourth condition is right. Now let's go to the fifth condition. On the fifth condition, 1, 2, 3, 4, 5. Only B is 1 and everything is 0. So let's change to that. B to 1. And everything is 0 and still LED is on. Let's go to the sixth condition. 2, 3, 4, 5, 6. On the sixth condition, B and D is 1 and everything is 0. So B and D is 1. Still LED is on. So my sixth condition is right. Let's go to the seventh condition. 1, 2, 3, 4, 5, 6, 7. On my seventh condition, B and C should be 1. B and C should be 1 and D should be 0. And still LED is on because my output is 1. Now let's go to 8th condition. 1, 2, 3, 4, 5, 6, 7, 8. On the 8th condition, A is 0 and everything is false. And the output should be 1 and my LED is still on. Let's do it over here too. And you can see LED is still on. Now let's go to the next condition over here. A is 1 and everything is 0. Where they have done that condition. Now the most interesting condition over here is the first time we are going to see 0. It means the LED should be turned off. For that, A and D should be 1 and everything else should be false. And you can see on the real circuit the LED is off because the output of the table is 0, and over here too LED is off. On the next condition, when A and C is 1 and everything is false, the light should be off. So A and C is 1 and everything is false. A and C is 1, everything is false. Still the LED is off because the result of this table is 0. On the next condition, I can do A, C and D to 1 and B to 0, and the output is 0, and so the LED is still off. Let's go to the next condition. On the next condition, I do have A and B is 1 and 2, C and D is 0. The output is 1, so the light is on. Let's do the same condition over here too. Okay, you can see that. Let's go to next condition over here. The next condition is C is 0 and everything is 1. C is 0 and everything is 1. And the output should be 0, so the LED is off. Let's check the same circuit over here too. C should be 0 and everything should be 1 and the LED is off. Let's go to the second last condition. Everything is 1 but D is 0. The LED should be on. LED should be on and my output is 1 over here, so it matches. The last condition is everything is 1 and the output is 1, mean the LED should be 1. So let's do everything to 1 and LED is still on. And on my simulation too, when everything is on, LED is on. As a result, you can see the result we got from the mathematics of a truth table is exactly same with my physical simulation and my simulation on TinkerCad. And this is one of the way to prove that your digital circuit is working good. Okay, finally, in our first hardware project, we have seen the given circuit, then we have made the truth table for that, then we just simulated everything in our hardware project over here, and we also did the similar project on TinkerCad and see everything. All those results match exactly as indicated, which simply justify the project is working successfully. Thank you so much for watching. Have a nice day.